Okay, in this video, we're going to show you how to factor by grouping. Now, before we go into that, we need to know why would we need this. Now, notice that we're pretty good at bottoms up and factoring quadratic trinomials and all that, but what happens when you maybe have an x to the third, x to the fifth, x, and some of these higher powers? So we're going to try to factor by grouping. First off, when you can group into equal groups. Like, notice that I can try to group these into groups of 2, okay? That's the first thing. You got to make sure it's in higher power and you can get them into groups. Now, before we go into the factoring by grouping, it doesn't always work. Same way with actually factoring quadratic trinomials by the whole adding, multiplying thing. Doesn't always work. Not everything's factorable. So here's how we're going to test this. First step, put them into groups. Next step, ask yourself what will divide out or what is common in each of the groups. In my first group, I know that both of them have an x squared, and that's about it. I'm going to factor it out of just my first group. Here, when I factor it out, I'm left with an x. Here, when I factor it out, I'm left with a positive 3. Second group, what am I going to factor out? Now, make sure, this is very important, that you put either plus or minus. If you're factoring out a positive, put plus. If you're factoring out a negative, put minus. I'm factoring out a positive 2 out of both of them. 2 times x gives me my 2x. 2 times 3 gives me my 6. Now, here's how you can tell now if it works. Look at your two groups. In parentheses, notice that both of the groups have the exact same thing. And what we're doing when we're actually factoring is we're removing, like here, we removed x squared from both of those terms. We removed 2 from both of those terms. Now my two terms have something in common too. I'm going to remove it from both groups. I'm going to move it out front. So both groups now have an x plus 3 in common. When I remove it, I'm left with, in my first group, I'm left with x squared. When I remove the x plus 3 from my second group, I'm left with plus 2, and I'm finished. That is now factored. You can multiply x times both of these, 3 times both of these. You can check it. It would multiply it out to give you the same thing. And that's it. Next one, we're going to work a couple more just to make sure we've got it. Factor by grouping, we're going to group into groups of 2. My first group has a 2 in common, and then both have x squareds. When I factored out of this, when I remove it, that's what factoring is, I'm left with only the x. When I remove the 2 from my 4, I'm left with a 2. When I remove x squared, I'm left with nothing. My second group has a 3 in common. When you remove the 3 from the first, you're left with an x. From the second, you're left with a minus 2. Again, both groups now have an x minus 2 in common. When we remove it from the first group, you're left with 2x squared. When you remove it from the second group, you're left with plus 3. That's your final answer. Now, you could check every once in a while. This might be like difference of squares, or it might be another quadratic trinomial or something that you could factor again. This is linear. It's done. It's x to the first power. You cannot go any further. All right, last one. First group, second group. First group has only an x squared in common. When you remove it, I'm left with a 3 and an x, and I'm left with nothing. You have to put that 1. Why? Because if you were to multiply this back out, you'd get 3x to the third. X squared times what gives you x squared, you do have to put that plus 1. The second group has not only a 3 in common, but a negative 3. So if you can factor a negative out, if they're both negative, always factor out the negative. If the first one's negative, always factor out the negative. When you factor out negative 3, you're left with 3x and a positive 1. And you would have been able to tell, hey, I don't get the same thing in parentheses, and you'd have known something was wrong. So both of them have a 3x plus 1. When you remove it, you're left with x squared in the first term. You're left with minus 3 in the second term. This was nearly difference of squares. Had it been, you could have went one step further, but since it's not, you're finished.